Good morning, students. Today we'll discuss about the integrals in mathematics for class 12th. So now we'll discuss about the integrals. Okay. So now we can say that integration is the inverse process of differentiation. Inverse process of differentiation. Okay, we all know what is the meaning of differentiation. Now, instead of using a differentiation or finding the differentiation, we are given a derivative and we need to find the original function. Okay, so that is the process called integration. Integration or we can say that integration or anti-differentiation 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 or anti-derivative. Okay, so that is I have asked integration or anti-differentiation or anti-derivative. Okay, now for example we have given, if you need to find the differentiation of sin x is called cos x. More example we have, if they ask the differentiation of e raised power x is called e raised power x. Or we can take example of differentiation of x cube by 3 is equal to x square. Okay, so now that is what they have asked. For now here cos x is the derived function of sin x and sin x is the antiderivative of cos x. Here also ex is the derived function of ex and ex is the antiderivative of ex. We say antiderivative or integration. And here x square is the derived function of this one. If I differentiate this, what I will get 3x square upon 3. So I got this. So this is the derived function of this and this is the antiderivative of this. That is called antiderivative or integration. Okay. So we'll now try to write some important formulas of antiderivative if of integration with respect to the derivative, that is differentiation. Then we'll try to solve numerical on that case. Okay, so now we have derivative here and here we have antiderivative. Okay, or we can say integration, integrals. Now we'll find, like for example we have xn plus 1 upon n plus 1. If I differentiate this, I got x is power n. Okay, now here if I integrate xn power dx, I got xn plus 1 upon n plus 1. Okay, so like this we find the formula for integration, that is x raised to power n with respect to dx is equal to x raised to power n plus n upon n plus 1. And if I differentiate this, find derivative of this, we got this one. Why? We have already done in the differentiation, that is upon n plus 1. So what I have got here? X power. Okay, so that is how we find the derivative here, and this is the integration. So now we'll find for more. Okay, now if I differentiate sin x, I got cos x. But here, if I find the cos x integral with respect to dx, I got sin x plus c. C here is a constant term. Okay, so likewise we can find. If I find the differentiation, that is I got first, second, I got third. Differentiation of minus cos x is sin x. Here, if I find the integration of sin x to dx, I got minus cos x plus. Okay, so that is how these are the important formula for this chapter for class 12th. Now we'll move to further. Okay, now here I find sin x cos x. Now we'll move to further on. Now we'll write more formulas here. That is, if I differentiate tan x, I got sec square x. Okay, now here if I try for the sec square x dx, I got tan x plus c. Okay, so now if I move to minus cot x, I got cosec square x, cosec square x. And if I try to find this cosec square x is equal, or with respect to dx, if I integrate, I got minus cot x plus c. I here got a value here minus cot x plus c. Okay, so this is what we have, the 5 formulas we have discussed here. Now we'll move to the next one, the 6th one here. So the 6th one will be tan x minus cot x. Now next one I will discuss sec x. So here I will try. Now the sec x. So now we'll move to the, that is the differentiation of sec x. So sec x will be what? Will be sec x tan x. Okay, here if I integrate sec x tan x is equal to sec x plus c. Sec x tan x, this way, sec x plus c. Now we'll move to the differentiation of, that is minus cosec x. Minus cosec x differentiation will be what? Cot x cosec x. So here I will try to find, that is for cot x cosec x differentiating with respect to x, which is equal to minus cosec x. Okay, so this is what we got here. So 7 formulas of the, first we have written the differentiation, then we have find the antiderivative, that is 5. First we have the derivative, then we have the antiderivative. So I hope you have the clear vision. Now we'll solve more numericals, but first we'll now write more formulas here so that we can easily able to apply them in the numerical. But these are the important. If we don't know the formula of these, we are unable to solve the numerical. Now we'll write more formulas. Now if I differentiate sin inverse x, I got 1 upon 1 minus x square. Okay, so now next if I integrate this dx with respect to So I got sine inverse x plus c. Okay. So now we'll move to the next formula. So now we have ninth, that is differentiating cos inverse x minus here. So I got this one. Okay. So now this is, now what will happen if I differentiate this? 1 minus x square is equal to minus cos inverse x plus c. Okay. If I move to tan inverse, differentiation of tan inverse x, we got 1 plus x square. No root is there. No root is there. No. So that is a formula for tan inverse x. Now we'll move to the differentiation of 1 plus x square is equal to tan inverse x plus c. Okay. So finally we able to find the derivative and the antiderivative. Okay. So I hope now you have cleared the basic difference between the derivative and the antiderivative. Now we'll solve numerical, so you able to understand and able to clear your doubts now. Okay, so let us see. But before that, let us try to write more formulas. We have written here only 10. 10 are very very less. So let us move to the next one. Next formula we have, that is, now we'll write to the next one here. So the next we have, that is 11th differentiation of ex is equal to ex. Now if I integrate ex with respect to dx, we got ex plus c. Okay, so that is how. Now we'll move to the next one. Okay, so now we have more formula here. If I differentiate log x, so what I will got here is 1 upon x. Okay, so here if I try to find the differentiation, that is integration, sorry, so what will be log x plus c. Okay, if I move to another one, that is, if I differentiate ax upon log a, ax upon log a is equal to ax. Now if I integrate ax with respect to dx, I got ax upon log a plus c. So now we try to sort it out. So these are the important formulas. Now we'll solve numericals where these formulas will be applied. Okay, so let us see. Now we'll try to solve numericals on this. Let us try to find the antiderivative. Now let us try to find the antiderivative. For example, we have one question here from the exercise from the NCERT, that is to find the antiderivative of this. So now we'll see that first of all we'll see this, the differentiation of cos 2x will be what? 2 minus 2 sine 2x. Okay, we have 2 minus 2 sine 2x. So sine 2x will be d by dx of minus half cos 2x. So this is an integral part of sine 2x. So if I need to find the integration of 2x, that is antiderivative. So first we need to find the derivative of the function. We need to find a function whose derivative is this. Okay, here the thing which is important is, first of all, before finding the antiderivative of this, we need to find a function whose derivative is this. So cos 2x, then differentiating we got this. So finally I got the integral of sin 2x is the minus half cos 2x. Okay, so find the integral of this. Now the second we have here cos 3x. So let us try to find the function whose derivative of that function is cos 3x, will be sin 3x. Okay, so now if I differentiate sin 3x, that is, now I got this sin 3x, so now will I have, that is minus, no sin, so cos 3x, no? So we'll have cos 3x, 3 cos 3x. Okay, so now we have cos 3x is equal to 1 by 3 of dy dx of sin 3x. Okay, so now here I can say integral of cos 3x with respect to dx, we have, with respect to dx, here we have 1 upon 3 sin 3x plus c. Okay, so likewise we can easily find this. Okay, so let us try to solve more numerical now on this. I hope it is clear now. We'll take more numerical on this antiderivative so that it will be clear to all of you. Now let us make it. So now we have the third question in my hand, that is to find the antiderivative of e to the power 2x. So first we need to find the function whose derivative is just e to the power 2x. So we'll have e to the power 2x. If I, no directly I can't do that. So differentiation of e to the power 2x will be 2e to the power 2x. Okay, so now integral of e to the power 2x will be half of e to the power 2x plus c. So first if we need to find the antiderivative of this, but first we need to find a function whose derivative is this. Okay, by differentiating I got this. So this is the this is how we find the integral. Okay, so we can write in one more step, that is e to the power 2x is equal to half of dy dx of e to the power 2x. Okay, so then we find this. Okay, so likewise we able to find the antiderivative of. So now let us try the next numerical we have next to find the antiderivative of this, that is ax plus b whole square. Ax plus b whole square. Okay, so here we need to find, then we have one more question here, that is sin 2x minus 4e to the power 3x. Okay, so we need to find a function whose derivative is this. So differentiation of ax plus b whole cube will be this one. So differentiating this, I got 3ax plus b whole square. Okay, so we need to find a function whose derivative is this. So we got this. Now ax plus b whole square is equal to 1 by 3 of d by dx of ax plus b cube. Okay, so ultimately I find the integral of this, that is 1 by 3 ax plus b plus c. Okay, so that is how we able to find the antiderivative of this function. So it is clear now, to find the antiderivative of any function, first we need to find a function whose derivative is a function of this. So that is why we find that. So we'll finally able to solve this numerical. Okay. Now let us take one more numerical. We have the fifth one. Now the fifth one will try to solve, that is this question we have, fifth one, sine 2x minus 4 e to power 3x. Okay, so first of all, we'll try to find the function whose derivative is this. So it will be cos 2x. If I differentiate, okay, it's got minus 2 sine 2x. So sine 2x is equal to minus half of d by dx of cos 2x. Okay. So finally I got this minus half of cos 2x, okay, plus c. Now we'll take this function here to find that derivative. Okay, so a function whose derivative is this. So we'll try to sort it out. That is e s power 3x difference. No. First we need to find the antiderivative. So first we need to find the derivative of this function. So I got this 3 e s power 3x. Okay, so finally I got 3x is equal to 1 upon 3 of d by dx of e s power 3x. Okay, so now what will happen? We got the value here, 3x is equal to e s power 3x. Okay, 1 by 3 e plus c. But here we have 4, will multiply with this 4. So now putting these two value in this, we got here, if I try to write here, the value will be of integral of this is what we got here is minus half cos 2x plus 4 upon 3 e raised power 3x plus c. Okay, so that is how we find the integral of this, that is the antiderivative. So if we need to find the antiderivative, first we need to find a function whose derivative is given in here. Okay, so that is whose derivative is the function whose antiderivative we need to find. So that is how we able to solve such kind of numerical based on one method. Okay, now we'll try to solve more numericals now. I hope it is clear now. If you have any doubt, you can ask. Okay, you can comment, you can share, you can like. So we have lot more questions to solve here. So now we'll move to the next part. If they have asked, that is to find the integrals, that is they have given the question they have given is in the very simple form, to find the integral of 4e 3x plus 1 dx. Okay, we have this. So how we'll try to solve this numerical? Let us first we use the property use and will divide like this. Next step will be, now 4 is constant, so we can take common here. Okay, plus we have x. Okay, so now we able to find. Okay, so 3x plus here 1 will be x plus 6. That is how we able to solve such numerical. Okay, so that is what I have given. So now we'll try to solve next integral. So the next integral we have here to find, that is they have given, that is to find x square. Okay, we have here, that is x square 1 minus 1 upon x square dx. We need to find the integration. Now, the question is to find the following integral. So how? First we need to multiply here, open the bracket. So I got 1 here. So dx, no, not like this. Dx minus, here if I multiply what? Dx. Okay. So now very easily I can solve such numerical. Okay, so this is what they have given, like we can solve such kind of numerical here. So now we'll try to solve more. Now what they have given is, that is to find the, we'll take the different types we can take here. We have one more type now, that is what they have is, question we have root x minus 1 upon root x whole square dx. Okay, so now how we can sort it out is in a very simple way. How? First we need to write the formula a minus b whole square. What the formula we have? A square plus b square minus 2 into ab. Okay, so now we can easily find what we have now, x plus 1 upon x minus 2 here. Okay, so now we'll try to solve the question here. So now we'll integrate individually. Plus 1 upon x dx minus 2 is constant, we'll take it outside. So here I have the integral formula now. We'll use it. Okay, so we have applied the formula. So here we need to remember, need to learn by heart all the formulas so that we can easily solve such kind of numericals. Let us move to the next one now. Now next integral, the type which I am taking is this one, that is, now I am taking, now it's ninth numerical I am taking, x cube minus x square minus plus x minus 1 upon x minus 1 dx. Now how to solve such kind of numerical, let us see. How to solve such kind of numerical now, we'll try to see. First we need to separate in two things. We need to separate out. plus, okay, now we need to separate out. So here also what will happen if I take x square common? So now my next step will be here I am writing x square dx plus dx I have. So what we can give by 3 plus x plus c. Okay. So likewise we can solve the formula, we can solve the numerical here. So now we'll move to the one. I will now take the complex one, but now I think of another type we have solved. So let us try to solve one more numerical of this type so that it will be clear to all of you. Okay, so let us try to solve what the question is. Okay, so now the question we have, we'll try to solve that. The question is x cube plus 5x square, x cube plus 5x square minus 4 upon x square dx. Okay, now how to solve it? By using the property that we need to separate all. Okay, like this. So now I am able to separate it out. So now I can say x plus 5 minus 4 upon x square dx. So now I can take x dx, separate it all, plus dx minus 4, I am separating it out, 1 upon x square dx. So now we are able to integrate minus 4. If I take this minus 2 plus 1, so 1 upon minus 2 plus 1 plus c. So I got here x square by 2 plus x minus 4 minus 1 upon minus 1 plus c. So I got the value here x square by 2 plus x plus 4 upon x plus c. Okay, so that is how we can easily solve such kind of numerical. This is the 10th one which I have solved from the first exercise. Okay, so we have lot of numericals we can solve. Okay, so they are the similar one which I can solve. Now try to solve one more very easy numerical. Now I will try, which will be for the trigonometric functions. Okay, let us try. Now I have cosine x square x upon cos x square x. So now try to sort it out. Now we have in my hand a very simple thing. Let us try to solve first. We'll see then. The question is, that is sec square x upon cos x square x dx. Okay, now 1 upon cos x square x is sin square x, sec square x 1 upon cos square x. Okay, so now I got this. So now that is I got tan square x, tan square x. We all know that is. Now we'll use the identity. Now tan square x we have, I can write the identity sec square x minus 1. Okay, so that we can easily able to find the solution here, that is sec square x dx minus dx. So we got tan x minus x plus c. Okay, so that is how we can easily find the solution. You can easily find the integral of this. Okay, so now let us move to another one, that is we have next question we have, that is now next question we'll try to solve of another kind we have solved this now. Very easily we can solve such kind of numericals here. So we'll try to solve one more question I have in my hand, that is 2 minus 3 sin x upon cos square x. Okay, let us see how we can find the integral of such kind. That is 2 up, we need to separate it out. Okay, 2 cos square x dx minus 3 sin x upon cos square x dx. Okay, so now let us try to solve it out in the upper section. Okay, so let us see how we can solve such kind of numerical. Okay, now what we have, 1 upon cos square x will be sec square x. Sec square x. Here, take 3 here. Now sin x upon cos x will be tan x, and 1 upon cos will be sec x dx. Okay, so finally we have the answer sec square x, that is tan x. 2 tan x we have minus 3. Now we need to apply the formula here for the tan x sec x. Okay, so now we have here tan x sec x integration this way. Okay, so that is how we have applied the formulas in this, finding the antiderivative and finding the integration of such kind of functions. So this is the first part of integrals. We'll try to solve, we'll solve in my next class. I will solve more numericals with more formulas. Okay, so now I hope it's clear to you. Now we'll try to solve more numericals on integration with next exercise. Okay, I hope, and if you have any doubt, you can ask, you can share, you can like my channel, and if you have any doubt, comment on my channel. Definitely I will give you answer soon. Okay, so that's all today.